Hello everyone, and welcome to this video called Introduction to Fractions, Improper Fractions, and Mixed Numbers. In this video, I'm going to be going through a version of a Knewton Alta assignment with this title. Please understand that the questions I see in this video may not be the same questions that you see if you work on the same Knewton Alta assignment yourself. But I'm hoping that the objectives are the same and that the questions are similar enough so that watching me do them here will help you in some way when you work on them on your own. So here is a Knewton Alta assignment, what it looks like. The left corner, you got the title of the assignment. Upper right-hand corner, you have this mastery bar, right, showing you how far along you've gotten in the assignment. Next to that, an activity log, where you can see the individual objectives in this assignment. So it looks like there are 3 objectives here, and you can see how far you've progressed in each objective. And beneath the current objective, back on the main page, there's a question related to that objective. And at the bottom of every question, you should be able to see a feedback button. So if you see any typographical errors or any issues at all with the question itself or the answer explanations, you can send feedback directly to the people at Knewton, and hopefully someone there, when their support staff, will get back to you shortly and help you resolve your issue. Next to that is a More Instruction button. So if you're having trouble struggling with a topic or a question, click on this, and you'll be taken to a page with further reading to do or videos to watch or both that are related to that particular objective. And then you'll be given questions that you can work on while still having the instruction available to look at. And you can work on the assignment that way. You can complete those problems in the more instruction area and progress through the assignment as much as you wish. All right. So the first objective I am seeing is convert between improper fractions and mixed numbers. Right. And the question, convert the mixed number 1 and 13/64 to an improper fraction. All right. Let's do that. So a mixed number, they give us 1 and 13/64. A mixed number, right, has a whole number, and then next to that, a proper fraction. Okay, a proper fraction is a fraction, you got a numerator and denominator, where the numerator is smaller than the denominator, right? 13 is less than 64. Now, a mixed number is really just shorthand for addition. 1 and 13/64 is the same thing as saying 1 plus 13/64. And what we're asked to do is put these together as a single fraction. Right? And this will be an improper fraction because the numerator, when we're done, is not going to be smaller than the denominator, right? When the numerator is not smaller than the denominator, it's called improper. Well, when you're adding fractions or adding anything really, when you're adding numbers, The denominators need to be the same in order for you to combine them. So when adding, denominators must be the same. So if I write that with a little letter representation here. So if I have a fraction with a numerator of, say, a and a denominator of c, and add it to another fraction with a numerator of, say, b and the same denominator c, okay, same denominator, you can put those together as another fraction with that same denominator of c. Whatever the denominator is, that common denominator, same denominator, stays there throughout. And what you're doing is adding the numerators to create a new numerator. All right, so this is what we're going to try to do here. Well, at the moment, I have 1 plus, 13/64, 1 and 13/64. If there's not a denominator, right, the whole number, they don't write the denominator for whole number. But every whole number, every integer, has a denominator of 1. You can write 1 as 1 over 1, or 1 divided by 1. Right, so that's the same as 1. Right, 1 over 8. And then we're adding to this 13/64. So clearly, they do not have the same denominator at the moment. All right, so I cannot put these together. Right, don't add these. Very often I see the mistake of, people will add 1 plus 13 make 14 and 1 plus 64 makes 65. Those are not the same value. You can go to any calculator in the world and verify that those would not be the same value. So what do we do? Well, what I'm trying to do is create an equivalent number, something equivalent to 1 that has the same denominator as the other fraction. So what we do is, I want to turn 1 into 64 here. I just simply multiply it by 64. Be careful. If I multiply the denominator by 64, that would turn this into 1 over 64, which is not the same as 1. Right? That's actually much smaller than 1 divided by 64 is much smaller than 1. So whatever you do to the denominator of a fraction, you must also multiply the numerator by that same number. So now what I have, after multiplying the numerator and denominator by 64, we have 64 over 64. 64 divided by 64, that anything divided by itself is 1. Anything over itself is 1. So this is the same as 1 that I had initially. And we're adding to this, the 13/64. And now I have what I want. Now we have what's over here. Now, whenever you're adding, you must have the same denominators. Right? And if the denominators are the same, they are common, when adding them together, that denominator sticks around. All right, you still have 64 down here. And you're just combining the numerators to produce a new numerator. So the new numerator, it would be 64 plus 13. And if you were to add, 64 and 13, that's 77. Here's 77/64. And this is what they're asking us for. Right? This is called an improper fraction here, right? The numerator is not smaller than the denominator. So this is an example of an improper fraction. And that's it. That is all they wanted. Now, this is a bunch of symbols, right? All these numbers, anytime you see a number written out, it's a symbol, an abstraction. So very often people have a hard time with this. You know, why do I need the same denominator, when we're adding? So I'm going to do this problem again, but with some pictures. All right, so I got some graph paper here to hopefully make this easier to visualize. I want to start filling in some blocks. All right, there's some graph paper. Let's do the side with the bigger squares. So we're looking at the number 1, and 13/64. All right. So first I'd like to identify, what do I consider to be 1 unit? All right. Now you can have 1 unit be a big thin strip of squares. You can have 1 unit be a big circle. Draw a picture and then say, this is 1 whole unit. What is a whole unit? And then everything else is going to be based on that. Now I'm noticing here that, the denominator is 64. The denominator is 64. So we're going to break things up. This means we're going to break whole units up into 64 pieces. So the denominator, tells me break wholes, right? Break whole units into 64 pieces, 64 equally sized pieces. 64 equal pieces. Well, one way to do that here, so it actually fits on my page, is if I made a square here that was 8 units by 8 units, yeah, 8 squares by 8 squares, right? So here's 1, 2, 3, 4, 5, 6, 7, 8. And then going up here, 1, 2, 3, 4, 5, 6, 7, 8. And here's what I'm going to call 1 whole unit. So here's 1 whole. This is representing the number 1. And it is broken up into 64 equal pieces, right? If I bear with me here, I'm just going across here, all these lines. If I go across, I should make these solid. Feel free to skip ahead and then go down all these other lines, on the paper. You'll see that this unit, right, this big unit I've drawn here, this 1 whole, is divided into 64 equal pieces, right? 8 by 8. This is 64 equal pieces. So this is what I was doing on the previous page, where this is 64 out of 64 is what I've got here, right? 60. I'll fill these, I'll color these in. So we're going to count, 64 out of the 64. All right, so next to that, I'm going to put on another whole unit. So again, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then here's another, what I'm calling a whole unit, right? There's another whole. So there's 1 again, 1 and 1. So all together we have 2 whole units. Now this is not 2 whole units. This is 1 whole unit that I've got here, and then 13/64 of the other whole. It's a piece of a whole, a fraction of a whole. That's what fractions are. They're parts of a whole. So again, I'll do the same thing here where I break this up, right? Again, denominators tell you how many equal pieces to break your whole units up into. Right? So I'm breaking this up into 64 pieces as well. So again, sorry about the time here. Right? I'm not going to do this for every problem, just trying to get a point across as to why we need a common denominator. Yeah. So there's 64, 64. Here's another 64, 64, 64 squares out of 64 for another whole. So we're asked here to, we've got one whole unit and 13 out of 64 of another whole unit. So one whole unit is, got all these squares filled in. Okay, I'm not going to perfectly color here, but, we're counting all of these. This is one whole unit, 64 squares out of 64 squares. So there's one whole unit. And then we're adding to that, putting on top of that 13 out of 64 of a whole unit, 13 squares out of 64. Here's, 8 squares in this top row here. And then I would need 5 more to make 13. So here's a picture of 13 out of the 64 of a whole. Put them together, you see how I have 64 squares filled in here, 13 here, for a total of 64 and 13 for a total of 77. If you look at all the colored in stuff, that's 77 64ths. Right. So one of these squares is 1/64 of a whole, and I have, 77 of those. So here's a picture of how to get that same result. Again, I know you wouldn't want to do this for every single problem. Maybe when you're first learning about fractions. So remember that denominator, think of what am I going to call a whole unit? All right, draw a picture, call that a whole, maybe a square or a rectangle or some of those are easy to draw. And then break it up into, however many pieces the denominator is telling you. All right, the denominator tells you how many pieces to break your whole units up into. And then we're taking a whole and then adding on 13/64. There's 64 of them here, 13 of them here, so 77 of those 64ths. I hope that makes sense. All right, but that's I think a nice illustration of what's going on when we're adding fractions, right? And why we need the same denominator, so that way all the units mean the same thing, right? All these little squares are the same size, and here are all these little 64ths. So back in the assignment, after all that, write 1 and 13/64 as an improper fraction. I'm just typing in, 77 over or divided by, divided into, these 64ths. And then let's submit. And then after you submit an answer, it'll tell you if you're right or you're wrong. Okay. You'll see progress. If you got it right, you'll see progress increase in the objective, also in the mastery bar. See, now I'm 8% through the assignment. And you'll be given some sort of answer explanation. Please read through the answer explanations, whether you got it right or wrong. If you got it correct, just read through it and make sure you understand why you got it right. Make sure you didn't just guess correctly. And if you got it wrong, definitely read through the answer explanation. See if you can figure out why you got something wrong, and hopefully you can learn from your mistakes for future problems. Okay, great. Okay, so they're pretty much doing the same thing I was just showing you here, but with circles. So I did it with a bunch of rectangles and squares, a bunch of blocks on some graph paper. This is model improper fractions and mixed numbers. So name the improper fraction, right? Then write it as a mixed number. So here, so remember on my paper in the first example, I drew that big square and I called that one whole unit, and then it was broken up into 64 pieces, so the denominator would be 64 divided by 64. Well, here I've got a circle, right? A circle is considered one whole unit in this picture. And you see how this circle is divided up into 8 equal pieces. So my denominator is going to be 8, right? The denominators in these fractions will be out of 8. Now we might have to, simplify a fraction, but um, and then you count up, so there's one whole unit with 8 out of 8 pieces shaded in. So this would be 8/8, one whole unit. And then here's another whole unit, another circle broken up into these 8 equal pieces. And 6 of those 8 are shaded in. So I have 8 out of 8, and then 6 out of 8. Well, that's 8 here, 6 there. That's 14 out of these 8 that are shaded in. So the improper fraction presenting this picture is 14 out of 8, 14/8. Right? 14/8 are filled in. Now that is not simplified. All right. Now they're not saying in the instructions to simplify the fraction. Because 14 and 8 have a common factor. 14 is 2 times 7, 8 is 2 times 4. So this is reduced to 7/4. But based on the picture, things are broken up in 8 equal pieces. I should make this out of 8, right? I'm going to see what happens when I enter this. Now, if it says it's wrong, I'll simplify the fraction afterwards. Now, for the mixed number, how many whole units have we filled in? Well, there's one whole unit completely filled in, right? 8 out of 8, so that's one whole unit. And then plus, on top of that, added to that, are these 6 out of 8 pieces filled in the other circle, right? So this is 1 and 6/8 as a mixed number in this picture. So it's 14 out of 8, 14/8 as an improper fraction, or one whole unit and 6/8 as a mixed number. Wonderful. So again, you could reduce the fractions, right? Make this 7 out of 4 and 1 and 3/4, right? This is 1 whole and 3/4 of a whole, but they broke things up into eighths. So I think they, like they showed here, they want denominator to be 8. Okay. So we're back to convert between improper fractions and mixed numbers. All right, so again, I'll draw another little picture here, all right, whereas to, convert the improper fraction 21 divided by 8 to a mixed number. So I'll do this 2 ways. I'll show you with a picture, which will take a while longer than you probably want. But I'll also show you with, division, right? When you see a fraction bar, something numerator over denominator, that's division. So here's the paper from my last example. Yeah, we're given the fraction, the improper fraction, 21/8, 21 divided by 8. Right. So once again, I'm gonna make a shape here and call that one whole unit and have that shape be broken up into 8 equal pieces. Right, the denominator is 8. Now the circles are harder to draw, right, like in the previous example. So I'm not going to draw circles here. Draw rectangles or rectangles. Right? Those will be easy to draw on graph paper. Now, let's see. I could have a 1/8. That would be nice, easy way to break it up into 8. But I'm going to do a 2/4. So here's 2 squares up and then 4 squares across. This is 8 little squares here. All right, that's 8 little squares. I'm going to call this one whole unit. And that's 8 out of 8. Right? This is 8 out of 8. If I fill this, if I look up, this is 8 squares out of 8 squares. Well, that's not 21 of these little squares, right? So each little square inside here is 1/8 of a whole, right? 1 out of 8. Well, I need more then to make 21 of these, right? So here's another whole unit. So again, the 4 across, 2 up. There's another 8 little squares, right? Here's another 8 little squares. another 8 out of 8. Now, if you filled all these in, that's 16 eighths, right? This would be 16 eighths. Here's one and another one, so that's two whole units. Now, if I have 16 eighths, I'm trying to make 21, 16 to 21, I need 5 more. So again, here's another whole unit, 4 over 2 up. There's another 8 little squares. Right, so I don't want all 8 though, right? So I'm gonna start filling these in. Here's 8 out of 8. Here's 8 eighths. Here's another 8 eighths, right? That would be 16 of these 16 of these little squares. And then I need 5 more, right? So just this. It's filling in 5 of these little squares over here. So there's 5 out of the 8. For a total, right, when I add these up, 1 plus 1 plus 5 eighths, that's 21 eighths up here as an improper fraction, and then making a mixed number, that's 2 whole units and 5 eighths. 2 and 5 eighths. So that's what I'm going to enter, 2 for the whole number and 5 eighths. Now, instead of drawing pictures, because again, you might not have graph paper on you or want to take the time to do a picture for every single one of these, we can do division. Now, you may recall long division. We're doing 21, the numerator. So this is long division down here. So let's say division. So the numerator goes inside the division symbol, right? This is the long division symbol. And the denominator goes outside, 21 divided by 8. And then you start thinking, go left to right in the 21 digits, thinking about how many times does 8 go into these numbers. Now, does 8 go into 2? No. Does 8 go into 21? Yes, and it goes into 21 2 times, right? You got 8, 16, 24. 24 is too big. So 8 goes into 21 2 times. All right, so that's the division step. Then you multiply, right? 2 times 8 is 16. And then you see what's left over, right? Subtract. 21 minus 16 is 5. And we're at the end of the number, so I'm done here. So here's what's called the quotient. This is your whole number, right? The 2 and the mixed number. And then down here, though, what's left over? This 5, when I finish division, that's what's left over. There were these 5 eighths left over, so that's going up here, right? So quotient, how many times, the denominator goes into the numerator even, how many times the denominator goes into the numerator is your whole number. And then what's called the remainder, right? This 5 would be called the remainder. That's going to be the numerator of the proper fraction part of the mixed number. So either way you do it, you can see it as 2 and 5 eighths. So 2 and 5 over 8. Check it out. Wonderful. Again, they do the long division thing. And quotient is how many times your denominator goes into the numerator. And then, the proper fraction part of the mixed number is remainder, what's left over, the 5 here, over the divisor is the denominator, right? Divisor is the denominator. Great. All right, so another one where we're given a picture like I've been drawing, but with circles, and asked to, write what's colored in, right? What is represented by this picture as a mixed number and an improper fraction. So again, here a circle is representing one whole unit. And you see how these circles are divided into 4 equal pieces. So the denominator of these fractions is going to be 4. So I'm going to fill those in right now. Now in this first piece, there are 4 of these fourths filled in. So that's 4 out of 4 plus, and then what's shaded in the other circle is 2 out of 4. 2 fourths. So 4 of these fourths plus 2 of these fourths makes 6 of these fourths. So 6/4 is being represented by this picture, the shaded area. That's my improper fraction, the improper fraction being represented. And then if you're doing a mixed number, this full circle, that's 1 whole and then 2/4. So 1 and 2/4 for the mixed number. So again, a mixed number is a whole number attached to some proper fraction, where the numerator is smaller than the denominator. And there you go. And they say don't simplify, right? I know 6/4 can technically be reduced to 3/2, 3/2, because of the common factor of 2. And 2/4 is a half, right? 2 out of 4 here, that's half the circle. But they don't want us to simplify. They just want us to write it. What is the picture representing? Great. All right, moving on. So understand the meaning of fractions. All right, so I've already discussed this a little bit, right? Remember, if you think of a shape as one whole unit, and then you break that shape up into so many equal pieces, the number of pieces you break it up into is the denominator. It's what you're dividing it into, dividing by. So down here, right, name the fraction of the shape that is shaded in the figure below. So if I consider this square one whole unit, and you see how it's broken up into 9 equal pieces. So that's the denominator, or the fraction that's being represented here, not out of 9. And then how many of these ninths are shaded in? We have 3, 6, 7 of these ninths are shaded in. So the shaded area here represents the fraction 7 out of 9, 7 ninths. And that's it. That is all they want. Again here, what fraction is being modeled in the figure below? So again, the shape they're drawing represents one whole unit. And you see that unit, that picture, that shape, broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9 equal pieces again. These are little thin strips, but they're all the same size, right? We're breaking these shapes up, we're breaking these whole units up into equal pieces. And every single one of them is shaded in. So 9 of these ninths, 9 out of 9, are shaded in. So that's what they want us to do, right? Again, broken up into 9 equal pieces. So the denominator, 9. And how many of those are shaded? All 9 of them, right? So 9 out of 9, which I know is 1. I know that's 1, but they ask us to, not simplify here. 9 out of 9. Okay. So now we're back to, converting the improper fraction 94 ninths to a mixed number. So once again, you can draw a picture, right, with some shading, or do division. Right? And again, I'll do both. I'll do both. I know I said I wouldn't do all this, but in the beginning of the video, but might as well. So we're given 94 of these ninths to write as a mixed number. So again, the denominator is 9 here. So I'm gonna draw a shape that's broken up into 9 equal pieces. Now you could do a 1 by 9 rectangle. I'm gonna do a 3 by 3. This will give me 9 little squares inside of it. So here's 1 unit. That's what I'm gonna call 1 unit here. And you see how inside there are 9 little pieces, 9 equal pieces. So this is 9 out of 9 here. If I shade all those in, I'll shade all of them in a second. Well, that's definitely smaller than 94 of them, right? If I shade 9 of them, I want to shade in 94 of these little squares. So here's another one. Right, this is another whole unit. And, I'm going to break it up again into 9 equal pieces. There's another 9 out of 9. And maybe I will start shading them in too, right? So here's 9 out of 9. Here's another 9 out of 9, the whole unit. Now, if I'm adding them together, that's 18 of them, right? That's 18 squares filled in, 18 out of the 9. And I'm trying to get to 94. All right, so I'm going to add a bunch more here. Okay, so here's another one. Here's a third. Here's a fourth unit, a fifth unit, a sixth, a seventh unit, unit number 8, unit number 9, number 10, number 11. Okay. Again, I know you probably wouldn't want to do this because it takes a bit. But here's another whole unit, another whole unit, another whole unit, and so on. Now, what I've drawn here is 11 of these. We're not going to get to 11. All right. Let's start counting the ninths. If I fill this in, this is another 9. So that was 18 plus another 9 of these is 27 ninths. Then another 9 would make 36 ninths. Another 9 make 45 ninths. Another 9 makes 54 ninths. 54 of these ninths. Another 9 would be 63 of the ninths. Another 9 is 72. And we're trying to get to 94 of these. Yeah. And then another 9 is 81. And another 9 is 90. All right, but if I fill in the rest of this, if I do another 9, that'd be 99 ninths. That's too many. All right, so again, all these here up to this 10th unit, this is 90 ninths that I've filled in. 90 of these squares. So I just need 4 more. So yeah, what's left over to make 94? So I would need these 4. Here's 4 ninths at the end here. So all these are 9 ninths, 9 ninths, 9 ninths, 9 ninths, up to the 4 ninths. Right. Now 90 ninths, if I'm writing a mixed number, right, that's 10 whole units, right? You can count them. That is 10 whole units. And then you have the 4 ninths as the proper fraction part. There's your mixed number, 10 and 4 ninths. Again, that is a very long-winded way of doing that, but still doable. Once again, though, you can just do the long division procedure. 94 inside, divided by 9 outside. Now 9 goes into 9 one time. And then 1 times 9 is 9. Subtract, you got 0 here, and then drop to 4. And that's it. Really, because, you're in the tens spot here. So really, it's 9 goes into 90 10 times. And then 10 times 9 is, 90. You can really throw zeros out there, and then 94 minus 90 is 4. And then, you're done. 9 goes into 4, 0 times. It doesn't go into 4. So 9 goes into 94 10 times. There's your whole number. That's, again, called the quotient. I didn't write quotient earlier, but that's called the quotient, how many times the denominator goes into the numerator. And then here's your remainder, right? That's going in the numerator up here of the proper fraction part of the mixed number. So 10 and 4 ninths, right? 10 and 4 ninths. So back on the assignment, 10 and 4 over 9. Right. All right. Moving on. So this is something where I'm just going to do the division this time. Right. As you've seen a couple of these now. So let's change, 67 19th to a mixed number. Right? This is an improper fraction to start. So we're given 67 19ths. So again, imagine I have 67, I have a whole, break it up into 19 pieces. So 19 out of 19, another 19 out of 19 would be 38 19ths, another 19 out of 19. So really what you're doing is you're thinking of multiples of 19 here. You know, there's 19 19ths, then add 19 again, 38 19ths, add 19 again, it'd be 57 19ths. Now if I add 19 again, that'd be too big. You know, if I add 19 again, that would take me to 76. All right. I only want to get to 67. But you see from 57 to 67, I need to add 10 more. So 19 19ths, that's 1, 38 19ths, that's 2, 57 19ths, that's 3, and then I would need to add, 10 19ths to give me 67 19ths. So this would be 3 and 10 19ths, 3 wholes and 10 19ths left over. So you could think of that way too, like if instead of drawing the picture, or do the division. Again, very simple. Like how many times does 19 go into 67? Well, we just saw 1, 2, 3. Right? 4 is too big. So it goes into 67 3 times. 3 times 19 is 57. Subtract, you got remainder of 10. All right, so 3 and 10 19ths for the mixed number version of 67 19ths. 3 and 10 19ths. So once an objective is completed in these assignments, they usually, you can see the circle filled in with the star. They tell you it's done. Great. So back to the just picture stuff. Again, these should be no problem. Right? Just remember, one shape on its own is considered one whole unit. So here I have a whole unit broken up into 3 equal pieces. So my denominator has to be 3. And in this whole unit, there are 3 of them filled out. And this other whole unit, there are 2 of them filled out, making a total of 5 of these thirds, right? So this is a picture representing the number 5 thirds, 5 over 3. Now, if you were writing a mixed number, that would be 1 whole unit filled in and 2/3 of a unit filled in, 1 and 2/3, but they wanted the improper fraction here. 5 of the thirds are filled in. Great. So another one like that where, what fraction is being modeled in the figure below. So you have 2 units represented here, right? Each individual shape represents 1 whole unit. And they're divided into 1, 2, 3, 4, 5, 6, 7 equal pieces. Each of these is divided into 7 equal pieces. So the denominator must be 7. And then how many of these sevenths are shaded in, are colored in? Well, we have 7 of the sevenths filled in here, and then just 1 of them here. So that's a total of 8. So this is representing 8 sevenths. Now, if you were writing a mixed number, that would be 1 whole unit and 1/7, right? 1 and 1/7. But they wanted the improper fraction 8 out of 8 of sevenths, 8 sevenths, right? Great. So that objective is done, right? The meaning of fractions, right? Denominator again tells you how many units to break a whole up into, right? Take 1 whole unit and break it up into this many equal pieces. And the numerator is, how many of those pieces are you counting, right? How many of those pieces are you shading in? Great. And then once again, this one they want both, the improper fraction, mixed number. So here, each circle, right? Again, each individual shape represents 1 whole unit. So I have a whole unit here, and it's broken up into, looks like 12 equal pieces. You got 6 up here and 6 down here. So the denominator is 12. Right? So the denominator for the improper fraction will be 12. The denominator for the proper fraction of the mixed number will be 12, right? Because these whole units are broken up into 12 equal pieces. Now, the numerator of the improper fraction is just how many of those pieces are now filled in. How many are we counting? Well, 12 out of 12 are counted in this whole unit here, and it looks like 8 out of the 12 counted over here. All right, so 12 and 8, that makes 20. There are 20 of these slices, 20 of these pieces shaded in. All right, so this is 20 twelfths. Now, as a mixed number, now there's 12 out of 12, that's one whole unit filled in. So one whole, and then this one where there's only a part of the whole filled in, it's 8 twelfths, right? 8 of those 12s are filled in, 1 and 8 twelfths. So both of these, are represented by this picture. Wonderful. And again, same kind of problem. So here, each circle presents a whole, one whole number, 1, and they're broken up into 6 equal pieces. So the denominators on these fractions will be 6. Now for the numerator of the improper fraction, right, it's just how many of these 6 are shaded in. Well, we have 6 over 6, 6 out of the 6 over here, and then 2 out of the 6 for this second whole, making a total of 8 of these 6. Right? So this is 8 6 as an improper fraction. And then as a mixed number, right, there's one whole filled in, so 1 for the whole number. And then for the proper fraction, right, this one where there's not a whole filled in, 2 out of the 6 pieces are filled in, right? So this is 1 and 2 sixths as a mixed number. And I believe that's it. So I have completed all 3 objectives, all the problems they threw at me for the objectives. They'll say the assignment is complete. Hooray. You can rate the assignment afterwards. So yeah, hopefully a lot of that made sense with the pictures I was drawing, the pictures they were showing, right? What a fraction means. When you see a numerator or a denominator, then that denominator tells you take a whole number, take one whole unit, and break it up into that many pieces, that many equal pieces. And then the numerator simply tells you how many of those pieces you are counting, how many of those you're shading in, if you want to draw a picture like that. And then when you add fractions, right, you make sure that your denominators are the same, and you're only adding the numerators, right? After you get the denominators to be the same, you only add the numerators. That denominator does not change. The number of pieces each whole number is broken up to does not change, and you saw that in several of my drawings. All right, and like I said at the top of the video, please understand that the questions I saw here may not be the same exact questions that you come across when you work on this assignment yourself. But, hopefully the objectives are the same and problems hopefully are similar enough to the ones you're seeing that watching me do them here will help you out, when you work on them on your own. Or if you're working on anything involving fractions, right, that hopefully maybe this video will help you with those too. And thank you very much for watching.